Forgot to press the record button. Okay, so we're solving something of the form ax squared plus bx plus c equals 0. What we're actually doing, if this is the x and y axis, y equals 0, you're on the x-axis, and we determined that that was the x-intercept. Okay, x-intercept. So eventually we will be graphing, and if I think about my college algebras, when we graph, one of the first things we go after are the x-intercepts. If I'm in calculus, like my 212s, if we're graphing, one of the first things we do is we go after the x-intercepts. Okay. So we're going to be using the multiplication property, the zero property of multiplication, that says if a and b are any real numbers and you multiply a times b and you get 0, that means that either a is 0 or b is 0 or they're both 0. So that would say something like this. This would maybe 0 times 2. 0 times 2 is 0. This might say 2 times 0, which is 0. This would say 0 times 0, which is 0. It says if you're multiplying two numbers together and you get 0, one of them has to be 0. Or they both could be 0. So let's take it to our factors. So this says that x plus 3 times x minus 4 equals 0. This is two things equaling 0 multiplied together. This would be my a, this would be my b. A times b equals 0. That means that a, which is x plus 3, equals 0. B, which is x minus 4, equals 0. Two things multiplied together give me 0. What x values, what would x have to be for that to happen? X would have to be -3, or x would have to be +4. So let's do a check. If x is -3, then that says that -3 plus 3 times -3 minus 4, that is 0 times -7. 0 times -7 is 0. So you set x factor equal to 0. And we would do the same with 4. So if x was 4, then we have that 4 plus 3 times 4 minus 4 equals 0. 7 times 0 equals 0. So it's taking each factor. See, a times b. A is a factor, b is a factor. It's taking each factor and setting it equal to 0.
So the answer is either -3 or 4?
Yeah, so that would be your answer.
Okay. So you have to find all the possible numbers?
All the possibles.
Oh, okay.
Now here's three things. Yeah. This is like saying A times B times C. I've got three things multiplied together. That says x equals 0, x plus 1 equals 0, or 2x minus 1 equals 0. This says x equals 0, x equals -1. Those two are easy. This says I need to do what? Add 1 to both sides, divide by 2, so x equals 1/2. By the way, the one you forget the most is x equals 0. Is the one you forget the most.
That's the answer.
And that's the answer. Those are the three values of x that would make that product 0.
Could you go back to number 1?
Mm-hmm.
So what would this be used in a business sense?
In a business sense?
Yeah, how would this be used?
There's a couple of things that can happen, and what we need it for, especially if I'm in calculus, is that we would do something called the derivative. And what the derivative does is it gives us a formula. We take that formula, what we're going to be doing next, and we would be factoring it, right? And then we would find what we call the zeros. In other words, the x values where things are zero. What that tells me is where something is a maximum or where something is a minimum. And if you're in business, you want to maximize profit, minimize cost.
Okay.
And it is part of the process of maximizing and minimizing. Another thing that happens is this, is that if I have, in this case I have 3 zeros, and I'm just going to put them any place on my number line, and I have a graph. This what can happen. Between these 2 zeros, I either have something that goes up and comes back down,
A hyperbola.
or I have something that goes down and comes back up if I'm graphing. This is considered to be a maximum because it's a hill. This is considered to be a minimum because it's a hill. That says between any 2 zeros, you either have a maximum or a minimum. So if I know the zeros, I know either I've got a high point or a low point between those 2 zeros. So between these two, I've got a high, and between these two, I have a low. That's called, in calculus, that's called Rolle's theorem. So it's one of the most useful things that we actually do that you'll be using over and over and over again. Okay, so now you notice, is this factored? No. So in order to do that, I have to factor first. So first of all, I need to factor. And yeah, this is easy enough. The leading coefficient is 1. 2 numbers that multiply together to give me 15 and subtract, because that's minus, to give me 2. The 2 numbers are what? 5 and 3.
I thought it was -2 that we have to subtract together.
Well, I set the signs. I'm looking for a 2.
Yeah.
So I know that is 5 and 3. That gives me a 2.
Yeah.
What kind of 2 am I looking for?
Negative.
Negative. So who's negative?
The 5.
5.
Yeah.
But I know what the 2 numbers are. They're 5 and 3. Now I have 2 things multiplied together that give me 0. So that says that x minus 5 equals 0, or x plus 3 equals 0. And some of you can actually at this point look and write your answer. And that's okay too. This says x equals 5. This says x equals -3.
Well, isn't that not the whole equation, though? Because you still have an x squared and a -15.
Now remember, we factored it. X squared minus 2x minus 15 is equal to x minus 5 times x plus 3.
Oh, okay.
Because if you multiply x minus 5 times x plus 3 out, it's x squared minus 2x minus 15.
Oh, yeah.
That's your original problem.
Yep. Okay.
And then this is the problem in factored form.
Yeah, I was just
Right.
confused. Sorry. Yeah, I understand.
Now, in this particular instance, what don't I see on this side that I should see? 0. So that means I need to subtract 45 from both sides. Now, the good news in this section, 5A, the factorizations are going to be easier than it was in the last section. And so leading coefficient's 1. So I want 2 numbers that multiply together give me 45 and subtract to give me 4. What are the 2 numbers? 9 and 5. And what kind of a 4 am I looking for? Negative. So 9 is negative and 5 is positive. Now I have 2 things that multiplied together give me 0. So x minus 9 equals 0, x plus 5 equals 0. So x is 9, x is -5. Those would be the 2 x-intercepts.